This is our Algebraic Reasoning Exam 1 for the year 2018. This exam has 16 problems total, the 14 first of which are multiple choice problems. So we'll go over all these problems, and I hope that this exhibit will be helpful to you. Determine whether the sequence is arithmetic, geometric, or neither. Then write a recursive rule and an explicit rule if possible. Well, the first term we have is 0.25, then negative 1.75. So one way to organize this is to just simply write this as a sub n, sort of a arrangement. So we have 1, 2, 3, 4, 5 terms. So 1, 2, 3, 4, 5. And the first one is 0.25. Next one is negative 1.75. Then negative 3.75. Then negative 5.75. Then negative 7.75. So these are all going down if you subtract 2, right? Negative 2, negative 2, and so on. So basically, we're looking for a minus 2. A sub n equals a sub n minus 1 minus 2. So the plus 2 ones, I can just go ahead and cancel those out. Geometric, arithmetic, we're going down by the same amount every time. So between arithmetic and geometric, we can cross out geometric. So based on this process elimination, B would have to be correct. And we could check this out in case you're subtracting 2. A sub n equals 2 point, okay, the explicit one, A sub 1. Okay, the first one is recursive, the next one is explicit. So if we want, for this one, A sub 1 equals 2.25 minus 2 times 1. So we're going to get 0.25. A sub 2, so that checks out. It's going to be 2.25 minus 2n. So we get 2.25 minus 4, which can be negative 1.75. So that confirms B is our correct answer. Next, 2, write the first 4 terms of the geometric sequence. So again, like number 1, you can just go like this and put n a sub n. Well, let's see, 1, 2, 3, 4. So let's just plug in 1 here. So for 1, we'd say a sub 1 is equal to 112 times 1/2 to the power of n plus 1, or 1 plus 1, or 2. So what that's going to be is 112 times 1/4, or 112 divided by 4. So I think that's going to be 28. We can try the next one. If we try a sub 2, we're going to get 112 times 1/2 to the power of 3, and that's going to be half of 28, or 14. So A is going to be our correct answer for this one. So we get 28, 14, and so on. A is our correct answer. Next, 3. Determine whether the relationship in the table shows a linear function. If so, write function. Well, we're going up here by 1.4. Between these different amounts. And so that would tempt us to choose answer choice C. But on the other end, our x values are increasing by 2. Okay, so our slope is going to be 1.4 divided by 2, which is 0.7. So we're going to have either choice A or B. And then just to go ahead and solidify this, if we say xy, and we know if x is 1, y is 2.3. So if we have 1 times our slope of 0.7 plus something is going to equal 2.3. Well, that that something's going to have to be, what do you have to add? Well, you're going to have to add 1.6. Okay, 1.7 plus 1.6 equals 2.3. For x equals 2, we have 2 times, well, actually we have to use 3, right? Because we have an input of 3. Let's go back to 3. So input of 3, we have 3 times 0.7 plus 1.6. We should be equal to 3.7. Check that out. So what we have is 3 times 0.7 is going to be 2.1 plus 1.6 is going to equal 3.7. Check. So B is our correct answer for number 3. 4. Now, based on the preliminary class I saw so far, which is the 7th period, this was the hardest question on the test. A bacterial colony starts with 2,000 bacteria growing at a rate of 15% per hour. Does the situation represent a linear relationship? If so, which linear function would you use to find local total population of the county? So when you grow at a rate of 15% per hour, okay, that is indicative of an exponential function and not a linear function. So basically, my understanding based on that is just, boom, it's just flat out not going to be a linear function based on a definition. What is it going to be? It's going to be, what is the equation going to be? It's going to be 20,000 times 0.15, 15% per hour is going to be 0.15 to the power of n hours, right? Population P depends on after n hours, so n can go up here, and that's what the thing's going to look like. Next, 5, use finite differences to write a linear function that represents the given data set. Now on the left side, we're going up in each of these instances up 1. On the right side, we're going, let's see, plus 25. And it tells you it's linear, so it better be plus 25 all the way along here, which it is. Okay, so, and our y-intercept is where time is 0. It's going to be equal to 45. So our equation is going to be f of x equals 25 times x plus 45. And you can see just by substituting things in for x that that's going to be the case. Let's see. Let's just make sure f of 1 should be 25 times 1 plus 45. That's going to equal 70. That checks. F of 2 is going to be 25 times 2 plus 45. That's going to be 95. Check. Yeah, that's right. So it's going to be this first one here. It's choice A. Next, 6. Which following functions best models given data? Well, looks like all the choices are linear, and it looks like we're going down every time. So you're going to have, as x increases, y decreases. So we're not going to have answer choice A, nor are we going to have answer choice D. And the slope they gave is negative 6.26. So it's just a matter of finding out what it is. Now, between these two, your y-intercept is going to have to be greater than this 34.5, because from 0, you had to subtract something from that to get 34.5. And so that thing is going to be 40.76. And you can look at it this way. If you do a table set up like this, if we have xy and we want to have 1 and 34.5, we have 1 times negative 6.26 plus something equals 34.5. So I can just say x, not to confuse with that x. So we have negative 6.26 plus x equals 34.5. So we add 6.26. We have x equals it's going to be 40.76. So the correct answer is C. Next, 7. State whether the table represents an exponential function or not. If the table represents an exponential function, write the common ratio and function relating variables. And so we can take these r's, and r is going to be equal to a sub n divided by a sub n minus 1. And so our first term is we're going to have 360 divided by 240, which is going to be 1.5. Next, we're going to have r is equal to 540 divided by 360, also 1.5. And then we're going to have 810 divided by 540, also 1.5. So that's going to be it. Our common ratio is 1.5. So we know that it's not going to be A or D. Next, between B and C, well, the way the thing works out is you put your starting amount, in each case we have that, times the base to the power of x. So C is our correct answer for number 7. Next, 8, determine whether the relationship shows a linear exponential function and write the function represented in the table. Well, if we add, we have 24, but look at, they're getting bigger than that. So it looks like what times 12 equals 36? Well, 36 divided by 12 is equal to 3. So we say times 3, and then 3 times 36 equals 108. $108 times 3 is 324. And then 324 times 3 equals 976. So our base is equal to 3. So that's gonna boil down to B as your possible right answer. The only thing we have to check yet is, does this thing work? If we plug in 1, we should get 12. So 4 times 3 to the 0 power is going to be 4 times, actually 3 to the first power. 4 times 3 is 12. Then for 2, we have 4 times 3 squared, which would be 4 times 9, or 36. So that checks out. 9, which of the following functions best models the given data? And we're given linear choices, linear choice A and B, and exponential choices C and D. And we notice the data is going down. So anything that shows an increase, like this exponential function D, is not going to work, nor is this one B, that is a linear function that increases. So basically, we're down to now, are we a linear or an exponential function? That's going to tell the story here. So what we have is, we have 18.5 minus 12.2, so that's going to be, what is it, 6.3 minus 6.3. Then we have this one here, 26.7, 18.5. That's going to be, what is it, 8.2. And so we don't have a linear situation. So it's not going to be that. And then this next one would be 13 point something. And what is our ratio going to be? Well, it's going to be this, any term divided by its predecessing term. So we could say 40 divided by 60.6. And what do we get for that? I'm going to go reach. I'm not going to go for an on-screen calculator this time, but rather just a separate little TI calculator in hand. So 40 divided by 60.6, get 0.66. 0.660. Anyway, 0.66. It's going to be answer choice C. Next, 10. Determine whether the table represents exponential or linear function and explain why. Well, if we subtract, okay, we're going to have 59.05 and subtract out 53. Well, we're going to go backwards, right? So I'm going to put 53.14 and subtract out 59.05. So that's subtracting backwards, which isn't going to be as friendly looking. But we're going to have minus 0.91, is that right? So 5.91, is that right? If we take 5.91, if it was 6, it would be exactly, let me see, yeah, I think that's going to be right, isn't it? Because if we add 0.91 to that, yeah, I think that's right. So 5.91 is about what it looks like. And we can try this one here at the end. 34.87. Subtract out, we get 1. It's going to be, we got to go the other way. That's going to be, what is it? 3.4 minus about 3.49 or something like that. Okay, they're not at all alike. Okay, so these ratios, the first one here, I mean, the common differences are not really that close. So we're not linear. It's common ratios just by process elimination. Finite differences do not go with exponential. Not linear again. So this would have to be it. So if we just took the ratios here, and I'm going to just do a couple of these. I'm going to put 53.14 divided by, this time, 59.05. And then we're going to have 31.38 divided by 34.87. Are we going to get anything close there? I think we are. So go on a calculator. Let's say 53.14 divided by 59.05. Get 0.8999. Okay. 0.8999. Next, we're going to take 31.38. And divide that by 34.87. And for that, we get 0.8999. Approximately constant. And so it's going to be that. D is our correct answer choice. Now 11, the value of a car that depreciates at a rate of 18% annually can be modeled using a common ratio of 0.82. If a car's initial value is $24,000, which function can be used to model a car's value annually? Well, the common ratio, R, is going to be the base of an exponential function. The exponential function is, according to the standard equation, y equals initial value, which we call a, times base to the power of x. And so base is going to be this 0.82. So anything without a base of 0.82 is wrong. Wrong, wrong, 82 is wrong. And our initial value is 24,000. B is our correct answer. Should have been an easy one. 12, Jenny shares a cookie recipe using social media with 3 of her friends. Each Jenny's friends shared a recipe with 3 of their friends. As this trend continues. So what we have is, we say 6th round. Okay, well, we have n, a sub n. In our first round, we have Jenny herself is shared with 3 friends. In second round, her 3 friends have shared with their each 3 friends. So we go to 9. Third round, we have, again, we multiply by 3, we get 27. So that's the third round. Fourth round, we're going to multiply by 3 again and get 81. The fifth round, we multiply by 3 again and get 243. And the sixth and final round, we multiply by 3 for the last time and get 729. So our correct answer for 12 is A. Next. A ball as it bounces returns to 75% of its prior height. The ball dropped initially from a height of 10 feet is going to reach about what height after 3 bounces? So after your first bounce, okay, you drop you drop from a height of 10 feet. Okay, so here's 10 feet. And after the first bounce, it returns to 75%. So right here, after the first bounce, we're going to go to 75% of 10, which is 7.5 feet. After the second bounce, we're going to go up to this height, which is going to be 75% of our 0.75 times 7.5. So we get 5.625 feet. Then we're going to come and bounce the third time, and we're going to have what our answer is right here. And that's going to be 5.625 times 0.75. Before that, we get 4.2 feet. So 4.2 feet. Another way to do this one is just say 10 times 0.75 to the power of 3. You're going to get 4.21875. Definitely our closest answer is D. 14. A tree's radius growth is seen in its annual tree rings and cross sections radius. Tree whose growth begins with an initial radius of 2 centimeters annually has an average radius growth of 0.5 centimeters. What would you expect the circumference of the tree to be after 11 years of growth? So basically you have a formula. So our radius is going to depend on, you're going to start with 2 centimeters plus you're going to add 0.5 centimeters annually times the number of years. And how am I going to say that? Well, for years, I'll say N for number of years. So if we want to find after 11 years of growth, our radius is going to be 2 plus 0.5 times 11. Well, what you're going to get for that is R is equal to, use the calculator, 2 plus 0.5 times 11. So I get 7.5 after 11 years. So R equals 7.5 centimeters. And we're given a formula for circumference. We have like composition function. So C is going to be equal to 2 pi R. So that's going to be, C is equal to 2 pi times 7.5 for a radius. Then we can put that in our calculator. We should know what it is already. So we have 2 pi. I'm not too familiar with this calculator, where the pi key is. And since I don't know where it is, I can just do a substitute, can't I? I can say times 3.14, so 2 pi times 7.5. So I'm going to get 47.1. So the closest answer to this is obviously A. Next, 15. The table below shows data from linear relation. What is the finite or common difference in this function? Mark your answers using the grid provided. Basically, our difference, and they tell you what it is. They say our common difference D is equal to A sub n minus A sub n minus 1. So we can take our common difference equals 5 minus 2.3, which equals 2.7. We can see 2.7 is what you add from one term to get to its next. So D is equal to 2.7, so we mark 2.7 here, and you don't have to put a plus sign in this case. So 2.7. 7. And we can put these three things, the 2 decimal point 7. And you can put a plus sign here, but it's assumed plus already if you don't put darken in the plus sign. Now, the last one we have in this test is number 16. The table below shows data from an exponential relation with common ratio of this function. Well, again, we had r is equal to a sub n divided by a sub n minus 1. So in this case, we have any two terms that are adjacent. So we can have 20 divided by 80, which is equal to 1/4. And to put this in a grid, standard decimalized grid, that's going to translate to either 0.25 or 0.25. So we can just fill that in here. I'll put in 0.25. 0.25. Well, that's it. Shouldn't have been that hard of a test. Good luck. Thanks for putting up with the thunderstorms outside. It's good to be inside, sheltered from that. And as always, thanks for viewing.